Hello everyone. Thank you for giving the opportunity. I'm Monica Singh. So my team, me and Chirag Dave, we worked on collaborative filtering recommendation algorithm research paper under the guidance of Dr. Su. So we've worked on an algorithm that is based on association rule and clustering techniques. So the summary of the paper is that right now the recommendation systems are widely used in e-commerce applications. They are helpful in improving the user engagement and increase the revenue. Most of the recommendation system use the collaborative filtering techniques, which is the most successful techniques in the past recent years. So but a key challenge to this is that the cold start situation. Sometimes we got the scalability and sparsity issue due to the cold start situation. Cold start situation is a situation when a new hotel or a new user is added to the recommendation system, when the performance is not as good like for the previous data or the data that we have already in the system. So to solve this problem, we proposed a new algorithm that is based on the collaborative filtering, but we use both association rules and clustering techniques. For association, we use the FP growth algorithm instead of a priori because in the FP growth algorithm, it goes only through the two scans, whereas a priori algorithm requires multiple scans. The performance of our algorithm is much better when we go with the FP growth algorithm. So in the next slide, we will go through the introductions. So Chirag will give you the introduction part and the related work part.
Hello everyone. So let's look at the introduction part. Recommendation system plays a very important role in today's times, and it caters to a variety of different domains such as book recommendation, movies recommendation, TV shows, media, news, e-commerce, restaurants, hotels, places to visit, etc. like that. The one of the major example we can see is Netflix. They suggest what to watch, Amazon Prime, and that one. And when we are traveling, hotel booking sites, flights, flexible dates, such as that, like that. So our focus is a hotel recommendation system, which we are discussing here. So hotel recommendation system have gained a huge popularity, especially post-COVID times, because of the rebounding travel industry. And if you are looking at the statistic right now, it's even higher than the what travel used to be previous COVID times. So it is getting very much popularity. Hotel recommendation systems recommend the hotel to the user based on the preference of the users. So conventional recommendation system method are categorized into the three groups: collaborative filtering approach, which is recommended based on the user item historical interaction such as rating or feedback, and the content-based approach extract the mutual information between the user and the system to suggest the recommendation, and the hybrid approach, which is a blend of both, which integrates the multiple ways to state the recommendation. Now let's look at the another part which my project partner have discussed. The cold start is the major issue everyone facing. Either it's a hotel industry recommendation system, or a movies watching recommendation system, or a shopping recommendation system. So what is the cold start problem? If it's a new user, new item is, so they both cannot reach each other. The main part is there has to be some common or mutual ground to reach each other. Like the new user has to reach the new item if that item is really the user's end goal. And so that's the thing. But let's look at here. Cold start problem is one of the major issue which hinders the performance of the recommenders, which we can see if the user are getting non suggestive suggestions, non-reliable suggestions, they lose the interest and stop looking through that website or through that system. So that is one of the major issue. The new user will be given non-personalized recommendation until an adequate number of ratings are collected for the user. Which we discussed earlier, the possibility that the new item will be recommended to the user is very minimal. This problem should be addressed because the initial recommendation given to a new user plays an important role in deciding the user's satisfaction and retention, which we discussed earlier. Only if good quality recommendation is given, then the user will come back to the site or will finalize their deal, or purchase the product through that site. In this paper, we proposed a personalized recommendation approach that joins the association rule technology, user clustering technology, and item clustering technology. Users are clustered based on user ratings on items, and each user's cluster has cluster center. We can look here the cold start problem in the diagram. Easy to understand. It's a picturesque thing. The recommendation joining association rule, user clustering, and item clustering collaborative filtering is more scalable and more accurate than the traditional ones right now. So the next part is my the related work, which my project partner Monica will discuss.
So in the past years, many work has been done on the recommendation system. So if we go through all the papers, so all papers provide either one of the two approaches. The one is the content-based filtering and other is the collaborative filtering. In the content-based filtering, the recommendation system use only the system and the user data. No rating data has been used, but the most popular approach is the collaborative filtering, in which they have used both the user history data, rating data, and the item data. So we use all kind of data we have, and then we find a relation between them, and we try to recommend the items based on all the data we have gathered. So in the collaborative filtering approach, mainly it collects the user ratings on items to predict user references, and based on the opinion of other users who share the similar interest, so we provide the recommendations based on the other user interest. So if the two users have similar interest or similar history, then we can provide the recommendation of one user to the other users. So in the collaborative filtering, there are two types of methods generally we use. The one is the user-based collaborative filtering and the other is item-based collaborative filtering. Can you move to the next slide, Chirag? Yeah. So user-based collaborative filtering is a good way. Is a good way to find a user interest item to find other user interest item. So in the user-based, we find the similarity between two users, and then we provide the recommendations. In item-based collaborative filtering, we find the similarity between two items. Like if a user has booked one hotel, if the same hotel is similar to the other hotel, then we recommend the other hotel to the same users. But the challenge of these two approaches is, again, as we said earlier, is the cold start problem and the sparsity. So to avoid or to overcome this challenge, we have proposed a hybrid filtering approach that will provide a solution to the limitations of the content-based filtering and the collaborative-based filtering. So what we have done, we have provide a hybrid approach that will join both the association rule technique and the user clustering techniques and the item clustering techniques, plus the association rules, so that we can overcome the cold start problem, and our system will improve. The performance of our system will improve whenever there is a new hotel is added or a new user will onboard to the system. So that we go through how we implement our system, how we implement the hybrid algorithm in the further slides. So in the next slides is the system design, what approach we follow, that Chirag will walk you through.
So let's look at the approach here. In this section, an outline of the proposed approach for solving the cold start problem in the recommendation system is drawn. The approach is to combine two existing approaches in a sequential manner. First, the FP growth algorithm is applied to expand the user profile, or we can say to enrich the user profile. With the help of this expanded user profile, K-means clustering technique is applied for recommendation, focusing on the new item recommendation. Let's look at the combination of both this approach breakdown. Association rule is a data mining process to determine all the associative rules that meet the minimum requirement, minimum support, and minimum confidence on a database. FP growth is a part of association rule. The pattern of association of the functionality associated with the data transactions, such as e-commerce activities for extracting data, The pattern of association rule will provide an overview of a number of attributes or certain properties that often appear together in a given data set. Next will be the k-means clustering algorithm, which we have looked previously, that we applied on the item, new item. So new k-means clustering algorithm is one of the unsupervised learning algorithm and simplest way to solve the problem of clustering. This procedure follows the simple and convenient way to define a set of specific data through a certain number of clusters k predetermined. Data set we have collected from the Airbnb hotel recommendation Airbnb's website. Now let's look at the system design. First, input the data to the FP growth algorithm to enrich the new user's profile. Second, we use the clustering process. Let me give you a brief idea of the diagram and then we can discuss here, so it will be better to understand. So we can look here, first of all, the new user, the FP growth algorithm is used for enriching the user profile, and then the enriched profile is supported here in the new hotels using the k-means algorithm, and the new hotels has been on that k-means algorithm has been used. So second, they use the clustering process. When scanning in FP growth, if the number of data frequencies calculated is less than the frequent item set and the value of the relationship strength is measured by the lift ratio, LR less than 1, then the item or combination of items will not be included in the next calculation. If it means the result of the rule can be determined. After that, with k-means clustering technique, we can recommend hotels to the new user. At last, the efficiency and accuracy of the result can be calculated with the root mean square error methodology. Monica, you want to explain more in the detail this diagram?
No, I think Chirag, you have explained everything like in
Okay,
detail.
sure. So let's move to the next part, which is experiment, which Monica will explain it.
So as we discussed in the approach, like the system we proposed, now is the experiment part, like how we implemented the system. So first we have done like data collection, as we mentioned earlier. We collected the data, we downloaded the data of Airbnb data sets from the inside Airbnb. So they have all the data based on the user rating, and they have like hotel listing data. After that, we apply the clustering techniques to improve hotel recommendation. So what we did, since we have like two type of data set, one is the hotel listing and other is the user booking data, user basically rating data. So in the hotel listing, first we like cluster the hotel based on the reviews, user reviews, and the user rating. So we created almost like 10 to 20 clusters, as you can see in the picture. So each color represent a different cluster. So that it will be easy to identify like how many clusters we have created. And in the left side, if you see in the diagram or the figure, you can see the number of rating, and at the bottom, you can see the price. So we have like clustered the hotel based on the price and number of reviews. So we can identify which hotels are similar to each other. So if two hotels are like fall under same cluster, so they are like they have the similarities. And if we are recommending one hotel, then in the same cluster, from the same cluster, we can recommend other hotels to the users. So this is the approach that we took while hotel clustering. So for that we use the k-means clustering algorithm. And in the next slide, if you see, next what we did, we have the user profile data as well, because we have new users, everything. So what we did, so we have the user profile informations. So for each user, like what hotel they booked and when they booked. So we have all the history of the all the history. So what we did, so if the information is like this information is about a hotel in which the user is interested in. So we have like all the information in the different data set. On that data set, in the next step, what we did, we use the association rule technique to enrich the user profile. Now, since we have the user review data set, we used this data set as a transactional data set because the association rules can be used only on transaction data set. So we use this data set as a transactional data set where we mine the frequent patterns using the FP growth algorithm. So we have we have everything like frequent patterns. So we decided the lift ratio. If lift ratio is greater than 1, so we consider only those patterns. So whenever a new user is added to the system, so we enrich the user profile, like what cluster they like based on the frequent patterns. So we use both the clustering data and we use both the association rules or FP growth item frequency data to enrich the new user profile. So for that, once the user profile is enriched, then we suggest we use the top and recommendation to the user. So we have the cluster data, we have the user frequent item set data. When a new user is added, we can know that user has if user booked only on cluster 1. So with the association rules, we can identify like user might book in cluster 2 and 3 because cluster 1, 2, 3 are in the frequent item set. So instead of recommending the hotels only from the one cluster, now we can recommend the hotels from other clusters also. So that way we handle the new user cold start problem. Also, if new hotel is added, then with the help of K-means cluster, it will automatically, based on the price and the ratings, it will automatically assign to a particular cluster. So it will be automatically recommended. So we don't have to do anything for that. Now, once we have the recommendation output, now we have to check the recommendation quality using the matrix. So we use for the quality measurement, we can use the precision, accuracy, recall, and F1. So for that, for us, we have used the accuracy and precision. Like we are expecting like from cluster 2 and 3 hotels should be recommended. If our recommendation system recommend a new user from that clusters, then we can assure that our recommendation system is working fine. So to measure the accuracy, so in the next step, I will explain you in detail like how we measure the quality of the recommendation system. So as you can see, so what we did, we have suggested the integrated approach that is combine the clustering and the association rules technique. So what we did, we used only the clustering technique first, and with the clustering techniques, we try to measure the precision and accuracy. So what we did initially, only for the 10 users, what we did, we measured the accuracy, and then for 30 users, then for 50, then for 70, 100, 150. So we measure the accuracy using only the clustering techniques. If you see the blue line, that represent the what accuracy and precision we got while running the algorithm. But in our approach, that is the integrated one, that is association rules and clustering techniques. So with that algorithm, we measured the precisions for 10 same number of users, like initially 10, 30, 50, 70. As you see, with association rules, our algorithm is not performing better initially, but as soon as we feed more number of users data, it will perform better because in the association rules, more data we have, our algorithm will have more frequent item sets, and we have better recommendation. That's why in this graph we have shown that as the number of users increases with time, our integrated approach or the hybrid approach performs better than only the clustering techniques. Also, this also handle the new user and the new hotel issue, that is the cold start situation. So this is what we have implemented and how we check the quality of the system. So in the next slide, Chirag will tell you the conclusion that we have received, that we got from our experiment.
So let's look at the conclusion part. In this work, the assumption was that out of the hotels given as a recommendations, only those which are having prediction rate of more than 2 are relevant to the user. The user values were obtained for 200 number of users. The accuracy calculation of the implemented system is shown here. It contains the number of users who use the recommendation services, the number of the users registered in the system, and the accuracy value for the implemented techniques. The result clearly proves that there is a better accuracy. The combination technique is better than applying clustering technique alone. An accuracy of 79% and overall improvement of 28% was obtained on using the combination technique or the clustering technique, which we looked at here in the graph as well. So overall better efficiency is better. And let's look at the future work. For now, we used only one site hotel listing and reviewed data. Later, we can combine multiple site data, multiple location data to get better accuracy. Also, we might track user click activity data and web cookies to mine important features. New advancements are required to be researched that can drastically enhance the versatility of the recommender frameworks. So that's about it for our future work as well and conclusion part. And so thank you for this opportunity, Dr. Sue and Monica. Thank you very much for all your help.
Yeah, thank you so much. Thank you so much for giving us this opportunity. Yeah.
Thank you.
Thank you.